Hello, welcome to my channel. In today's video we are going to learn about the laws of indices. I'm going to take my time to explain all the laws of indices. Now without further ado, I would like you to like this video, comment on it below, and subscribe to this YouTube channel to grow the channel, of course. Now the first law of indices says okay, when numbers are written like this, say a like this, so this one under is called the base. It's called the base, and the one on top is called the index or power. Index or power. Now I'm going to be using power often in my illustration. Now the first law of indices says that the first law, I will write it as a raised to power 0 is equal to 1. Now anything raised to power 0 is equal to 1, but except when you are talking about temperature measurements. You can say, okay, the temperature of that place, the temperature of this zone is 30 degrees Fahrenheit, 30 degrees Celsius. In that case, the figure raised to power 0 is not 1. Or when we are describing the measurement of angles, say for instance, we have an angle and they say, okay, here is 30 degrees, that is not 1, okay? So when we are talking about angular measurement and temperature, we are not, that rule does not apply, but in indices, anything raised to power 0 is 1. Now, for example, you can have 5 raised to power 0, obviously is 1, 10 raised to power 0 will be 1, x raised to power 0 is 1. Okay, now let's look at law 2. Let's consider law 2. Law 2 says that a raised to power minus n is equal to 1 over a raised to power n. What does this mean? This means that whenever a number is raised to power a negative power, to remove the negativity, we just take the reciprocal of everything here minus, we just exclude the negative sign. By so doing, you have taken rid of the negative sign. Now, an example would be, for example, you have 5 raised to power minus 2. This will translate to 1 over 5 raised to power 2, which is obviously 1 over 25. Now, law 3 is just an extension of this law. You can have a over b when the power is a fraction, a over b raised to power minus n, for instance. So to get rid of this negative sign, when the base, this is a over b, the base, all raised to power minus n, to get rid of this negative sign, all you need to do is just to change the numerator, bring the numerator to the denominator. That is, take the reciprocal of this fraction. You move this b up, you move a down, and the negative sign is gone. That will be b over a all raised to power n. Okay, it's like taking the reciprocal too. So an example of this would be, let's say you have an expression like this, 5 over 3 all raised to power minus 2. This will be 3 over 5 all raised to power 2. As simple as that. Of course, this simplifies into 9 over 25, because this power is both shared by this and this. So we are going to see that in the fourth law now. So this is the fourth law of indices. You can have, this is a over b all raised to power n. This is the same thing as whenever a fraction is raised to by power, the power is both shared by the numerator and the denominator. So that would be, this one is the same thing as a raised to power n divided by b raised to power n. Okay, so, and that will mean, let's take an example of this. So this will be, for example, e.g. we can have 2 over 3 all raised to power 2. This is the same thing as, this 2 is both shared by the by this numerator and the denominator. So that will be 2 raised to power 2 divided by 3 raised to power 2, and that will be 4/9. So that is pretty much that law. Then let us look at another law, law 5. Now it is important to understand that in reality, a particular one question in indices, you can apply up to about 4 of this law or 5 of this law, depending on how the nature of the question is. Now let us go to law 5. Now law 5 can say is that, for example, x, or let me say a times b raised to power n, the same thing, and it's also almost similar to this other law. Whenever you have a product all raised by power, this power is both shared by each of the factors inside the bracket. So that will be a raised to power n times b raised to power n. So an example would be, for example, you have 3 times 4 all raised to power 2. That will be 3 raised to power 2 times 4 raised to power 2, and that would be 9 times 16. Now, of course, let's take another law. Now, there's another law that says that a raised to power x, for instance, times a raised to power y is equal to a raised to power x plus y. What does this mean? That when you have the same base multiplying each other, what you need to do is to take one of the base and you add the power. Why we are adding the powers is because there is a sign of multiplication between the two same base. So let me give you an example. An example can be 5 raised to power 2 times 5 raised to power 3. This will be, you can see that the bases are the same. Once the bases are the same, you take one of the base, 5. What do we do to the powers? We add the powers. Why are we adding the powers? Because there is a sign of multiplication in between the two bases. So that will be 2 plus 3, and that will be 5 raised to power 5. Okay, that is for that. And let's look at another law, law 7. The law 7 says a raised to power x divided, this is the case of division, a raised to power y. This law says that whenever numbers that are the same base are dividing each other, what you need to do is to take one of the base. As you can see here, the base here is a, the base here is a, so we take one of them, a. What do you do to the powers? To subtract the powers, that will be x minus y. Now let me give you an example. An example would be that you have, for example, 5 raised to power 2 divided by 5 raised to power 2. Now these bases are what? The same. You take one, that is 5. Now what do we do to the powers? To subtract the powers. So that will be 2 minus 2. So that will be 5 raised to power 2 minus 2 is what? 0. Now remember, there is a law that says what? Anything raised to power 0 is what? 1. So 5 raised to power 0 will be equal to 1. That is the answer. So let us look at an 8th law. Look at the 8th law. The 8th law is that we can have 8th law is a fractional power. That's a raised to power x over y, the same thing as the white root of a raised to power x. Now, what this means is, for example, e.g., you have 5 raised to power 2 over 3. You can re-express this as the third root of 5 raised to power 2. Okay, so that's pretty much it. So with this, if you understand these laws of indices, there is no question you will not be able to attempt in indices. Now, in the next videos, I'm going to be taking questions on indices, solving them, so you see step by step on how I apply these same laws in solving most questions in indices. Then let me take another case scenario. Okay, we call it indical equations. Now I'll take this as number 9. That if a raised to power n is equal to a raised to power n. Now you can see that on the left hand side and on the right hand side, the base is the same, but the powers are different. Now if this happens in indices, what we do is that we forget about the base and we equate the power. If a raised to power n is equal to a raised to power n, then n will be equal to n. An example will be this. If I have 2, if I'm simplifying the problem and I have 2 is equal to 2 raised to power 2. Now we can see that on both the left and the right hand side, the base is what? 2. So the powers are different. So we do what? We just equate the power. So we have, therefore, x will be equal to 2. That is how we solve that. Now, another case here is when the powers are the same and the base are different. Now we can have a case where we simplify a problem and then we arrive at something like this. If I arrive at something like this, m raised to power k is equal to n raised to power k. Now you can see if this happens and we have that the powers are the same but the base are different, then since the powers are the same and the base are different, we ignore the powers and we equate the base. The bases. So we have that what, therefore n will be equal to what? N. For example, if we are simplifying a problem and we arrive at a scenario, a situation whereby we have something like this. Say 5 raised to power 2 is equal to y raised to power 2. So in this case, we can see that the powers are the same. What do we do to the base? We equate the base. So that will mean that 5 is equal to y, or we say reverse it and say y is equal to 5. So these are pretty much all you need to know about the laws of indices. It's just a quick run through in no particular order. Now again, it's important to mention that there are some textbooks that might want to take any of this law as law 1, law 2, law 3. Now when we are solving problems in indices, we don't mention according to law 1, according to law 2. No, we just cite the law, we just apply the laws in solving the problems in no particular order. So if you know this video has been useful to you, I want you again to like this video, comment on it below, click on the notification bell icon below, subscribe to the YouTube channel and recommend it to your friends so that we can grow this channel together. Okay, thank you. I will catch you in the next one. Goodbye.